Greetings, math fans. All right, this is day 10, and we're going to do the derivative of two different functions. The first one is going to be natural log of x. So the derivative of ln of x. Okay, so let's start out with y equals ln of x, and let's rewrite it. And let's do e to both sides. So e to the y equals e to the ln of x. Now, you already know our properties of, if I say e to the ln of something, it's just that something, so it's equal to x. And so we have e to the y equals x. Now you can do implicit differentiation, so I'm going to do d by dx of both sides. Okay, so if I do d by dx of e to the y, remember I just get e to the y times dy dx. And d by dx of x is 1. So I divide both sides by e to the y, so I get dy dx equals 1 over e to the y. Okay, now what I'm going to do is I'm going to kind of come back here and do a little substitution. E to the y is equal to x. So I can say dy dx equals 1 over x. All right, so this is the deal. D by dx of ln of u, the natural log, because this is all taking the derivative of natural log of x. Okay, so it's d by dx of ln of u is equal to 1 over u du dx, right, with the chain rule. Okay, very important. Just as all the other ones are. Okay, not too bad. All right, let's try an example with this. Okay, so let's just clear this out of here. And we're going to do d by dx of ln of 3x squared. Okay, it's actually pretty easy. Again, you're taking this 3x squared, it's just going to be 1 over 3x squared, right? And then the derivative of 3x squared, which is 6x. So you get 6x over 3x squared. And then, of course, I simplify that to 2 over x. And that's your answer. Pretty easy, all right? So here, d by dx of ln of 2 over x squared. All right, so of course the first part is 1 over 2 over x squared. And then we use, that's times, and the quotient rule. So it's bottom times root of the top, which is 0, minus the top. So minus the top times root of the bottom, which is 2x, all over the bottom squared. So we can simplify this, that 1 over 2 over x squared is just x squared over 2. Times negative 4x over x to the fourth. And so I end up getting negative 4x cubed over 2x to the fourth. And that simplifies to negative 2 over x. So there are a lot of ways to actually simplify this. I mean, I could have taken the natural log of 2x to the negative 2 power, just use the product rule. That might have been a little bit easier. There are a lot of ways to do these problems. Okay. All right, so here's the next example, d by dx of ln of x cubed. Okay, well, again, using the chain rule, we're going to do the outside first. So we have 3 times ln of x squared times 1 over x. So we get 3 ln of x squared over x. Okay, well, that's not too bad. All right, so let's do derivative of log base a of x. So derivative of log base a of x. So what we're going to do is we're going to rewrite it using change of base, which you guys hopefully remember from Algebra 2. So remember, if I have log base a of x, that's saying natural log. I can use any base I want, but I already know natural log, so I might as well use it. Natural log of x over natural log of a. Okay, so let's take the derivative now of both sides. So d by dx of that and d by dx of that. Okay, and so that's going to equal, do you guys agree that ln of a, that's a constant, so I can just do this, 1 over ln of a, and then times the d by dx of ln of x, right? And of course, we already did ln of x, it's just 1 over x, so it's 1 over ln of a times 1 over x, which then I can write 1 over x ln of a. That's my answer. That's the derivative of log base a. Now, of course, using the chain rule, d by dx of log base a of u is equal to 1 over u ln of a du dx. All right. Now, just remember that whatever you're taking just to kind of highlight a couple of things here so you don't make the mistake, right? This a right here, that goes with the natural log, and when I'm taking the log of what value, that goes in front of that. Okay, so just kind of remember you put the right things in the right places. Okay, I guess if you look at it, the one that goes after the log, right after the log is the base, so that goes right after natural log as well. Okay, so let's do some examples here. Okay, d by dx of log base 5 of 7x to the 4th. All right, well, that's just going to be 1 over, remember the 7x to the 4th goes in front, and then it's ln of this guy right here, that base, ln of 5. And we got to do our chain rule, so we're going to do that now, and we have times 28, right? Bring that 4 down, so it's 28x to the 3rd. Okay, so I can kind of write everything. You have 28x to the 3rd over 7x to the 4th, ln of 5, and I can simplify it to 4 over x ln of 5. That's my answer for that problem. And this is the deal, math fans. When we're doing log differentiation, sometimes you want to simplify first. Sometimes. And when I say simplify, I mean use our properties of logs. Okay, you guys should know that, right? If I have log base 2 of, x to the 3rd power by the exponential, right? Or the power property, I can bring that 3 in front. If I have log base 2 of a times b, it's log base 2 of a plus log base 2 of b. Or if I have log base 2 of a over b, that's log base 2 of a minus log base 2 of b. So those are kind of the important properties you need to remember about logs. Okay, so let's actually look at this last example here. We should get the same answer. It's 4. Our answer came out to be 4 over x natural log of 5. I could have simplified this just a little bit, not really that big of a deal, but I have a 7 here, and then I have x to the 4th. I could have actually broken that up to addition, so let's delete this and just do this again. And you don't always do it this way. d by dx of log base 5 of 7x to the 4th. Well, I'm going to split it up. So I'm going to say d by dx of log base 5 of 7 plus d by dx of log base 5 of x to the 4th. Okay, and I'm going to do one more step here. I'm going to leave that first one the same. I'm going to say 4, it's really d by dx of 4 log base 5 of x. And I can put that 4 out on the outside. So it's 4 d by dx of log base 5 of x. Okay, so let me write it out here. D by dx log base 5 of 7 plus 4 d by dx log base 5 of x. Okay, of course, what is this? That's a constant. What's the derivative of a constant? 0. And let's do, it's plus 4. And log base 5 of x is just going to be 1 over, so it's times 1 over, and of course we're going to do x and we're going to do natural log of 5. So we get 4 over x ln of 5, which is exactly what we got for the first example if you look back at your notes. Okay, so it's not bad. All right, so the next several examples, I'm actually going to see if we can apply, basically using properties of logs. Again, you're not always going to do that because sometimes it makes it actually a little more difficult if you're using some of the properties. All right, so let's do d by dx of 6 log base 4 the square root of x. All right, so I think this is actually a really good one to rewrite. So we're going to do d by dx, and it's going to be 6, let's just kind of show a little work here, 6 log base 4 of x squared. So I can say that's equal to, the 2 goes in the front, or it's actually the 1/2, sorry. So the 1/2 goes in the front, and so we get 1/2 times 6 is 3. So it's 3 log base 4 of x. And that's really easy. That's just going to be 3 times d by dx of log base 4 of x, which is 3. And that's just going to be times 1 over x ln of 4, which then is going to give you 3 over x ln of 4. Okay, pretty easy. Okay, now I want to show you without rewriting it what happens. So I still need to rewrite it this way. I need to write d by dx actually of 6 log base 4 of x to the 1/2. And this uses the chain rule. Okay, so it's going to be 6, and then the log, derivative log is going to be 1 over x to the 1/2 ln of 4. Okay, and then we have x to the 1/2, right? So we're going to take this using the chain rule. So it's going to be times bringing 1/2 in front, and then x to the negative 1/2. Okay, and if we put everything together, we get 3 over x ln of 4. So I don't know. You tell me which one was easier. Okay, this one seemed a little. The chain rule was a little bit less steps, but again, always look to see. And I have some examples, definitely some examples where it's really obvious, where it's definitely easier to use properties of logs. But here, maybe not. All right, so let's do our next example here. So we have d by dx of log base 2 of x cubed. Okay, so this one's pretty easy. I think I'm just going to use a property of logs real quickly. I'm going to move that exponent down. So it's d by dx of 3 log base 2 of x. Okay, and then of course that's 3 d by dx of log base 2 of x. And that's really easy now. That's just equal to 3 times 1 over x ln of 2, which is then just 3 over x ln of 2. Okay, that was definitely pretty easy to use that one step and rewrite it. Okay, let's do another example here. D by dx of natural log of log base 6 of 4x. Okay, we'll definitely use the chain rule here. So this is working from the outside in, so natural log, so it's going to be 1 over log base 6 of 4x. And then I do the inside, so it's going to be 1 over 4x ln of 6. And then derivative of 4x is 4. So I put it all together, and I get 1 over x log base 6 of 4x times ln of 6, because these 4's cancel. Okay, so that's my answer right here. All right, so let's get a couple more examples here, math fans. D by dx of 1 over log base 4 of 3x. Okay, I'm definitely going to use the quotient rule here. Okay, just bottom times derivative of the top, which is 0, minus the top, so minus 1 times derivative of the bottom, which is going to be 1 over 3x ln of 4 times derivative of, okay, so it's times derivative of the bottom, and then derivative of the bottom, of course, is then times the chain rule, right? So you have to do times 3 all over the bottom squared. So log base 4 of 3x squared. Okay, basically the only thing you got that cancels, and then I have bring everything down. So this guy for the top, this goes on the bottom, so it's negative x ln of 4, and then it's log base 4 of 3x squared. Okay, just kind of put everything together. That wasn't too bad. Okay, another example. Just got lots of examples here, math fans. D by dx of ln of x cubed times the square root of x minus 1. Now, I think actually this is probably easier to do with properties of logs, because otherwise we're going to, you're going to do 1 over that, and then you're going to have to do the product rule with x to the 1/2 power, and actually it's a little nasty. So watch this. This is actually pretty easy. You can do d by dx, and I'm going to write this out as a product rule, right? So that's two products here. So it's going to be ln of x cubed, and it's plus because this is multiplication between here, so it's plus ln of x minus 1 to the 1/2 power. All right, and then I can do one more thing. I can bring that in the front, which I can do. So it's really d by dx, and I can move that in front too, right? So it's 3 ln of x plus 1/2 ln of x minus 1. Okay, then I have d by dx 3 ln of x plus d by dx of 1/2 ln of x minus 1. Let me just kind of cursor down here a little bit. And of course I can bring the 3 out. So can I just, I know I'm showing a couple extra steps here, but I think it's good. Okay, now it's really easy, right? Here, 3, what's the natural derivative of natural log of x? It's just 1 over x plus 1/2. Derivative ln of x minus 1 is going to be times 1 over x minus 1. Right? And then derivative, of course, of x minus 1 is just 1, so I don't have anything to worry about. And this actually was an easy one doing it this way, because now it's just 3 over x plus 1 over 2x minus 1. All right? And I know I always said write it as one fraction. That's only when things are kind of similar. Things are not similar here at all, and this is fine. This is a good answer. All right? That's not bad. Okay, I got one more problem before I do some more difficult problems here. Okay, d by dx of natural log of x squared over x plus 1. All right, this is definitely brutal if you do the quotient rule, you know, after when you're taking the derivative, so I definitely want to use some properties of logs here. So this is like d by dx of ln of x squared, and then this is division, it's minus d by dx of ln of x plus 1. That was a ton easier. Okay, and so this is going to be 1 over x squared times derivative of x squared is 2x. And this is going to be 1 over x plus 1, and that's it. So this is going to be 2x over x squared, so it's going to be 2 over x minus 1 over x plus 1. Okay, that was pretty easy. All right, now I'm going to do some, these are pretty nice problems here. Y is equal to x to the x power. Brutal! Oh, you're like, oh no, Mr. Curvis, do I use the power rule or do I use A to the u or a to the x, I don't know what to use. Well, we're going to kind of, this is what we're going to do. Okay, first of all, you really actually can't take the derivative directly. So what you need to do is you need to take the natural log of both sides. So if I do that, I get ln of y equals ln of x to the x. Okay, and I can have ln of y, and I can write this as x ln of x then, right? Now I'm going to take the derivative implicitly, and the derivative of ln of y is going to be 1 over y, and then of course dy dx. And this guy here is just going to be the product rule, right? So it's the first times the root of the second, so x times 1 over x, plus the second times the derivative of the first. So I get 1 over y dy dx is equal to 1 plus ln of x. Multiply both sides by y. I get dy dx equals y times 1 plus ln of x. And my last step is here, substitute that in for y. So let me write over here, I basically get dy dx equals x to the x times 1 plus ln of x. That's it. That's your answer. Okay? So very important that you substitute back again at the end, but it's a little tricky problem because x to the x. Okay, so let's try one more of these similar to that. Y equals x to the cosine of x. Okay, we're going to do the exact same thing, math fans. We're going to take natural log of both sides. Okay, bring the cosine down in front, so it's ln of y equals cosine of x times ln of x. And then I'm going to take the derivative with respect to x, dy dx. That gives me 1 over y dy dx is equal to, let's just do the product rule, so it's the first times derivative of the second plus the second times derivative of the first. Okay? And let's kind of put it together here. So 1 over y dy dx is equal to cosine of x over x minus ln of x sine of x. That doesn't matter which one's first there. And then my last step is going to be multiply both sides by y. So I get dy dx equals, and then what I'm going to do is I'm going to, as we did before, here's what y equals x cosine of x. So let's substitute that in there. So we get x raised to the cosine of x times cosine of x over x minus ln of x sine of x. Okay, and that is our answer. So that's actually pretty easy, but kind of remember that. You recognize that because you have the variable in the base and the exponent. All right, so I taught you guys, if you have like x squared or you have 2 to the x, right? This is a to the x, and this is x to the this is the easiest, what I taught you first. X to some a a constant, and then of course now we have x to the x, or x in this case here, x to the cosine of x. All right. So that's it for this chapter, actually, math fans. Just make sure you know how to do all the different derivatives of all the different inverse trig functions, e to the x, ln of x, a to the u, x to the x. There's just a lot of different types of trig functions that you definitely need to know, and you'll be good to go. All right? Have a great day, math fans. Adios. Goodbye.